Hello, my name is Will, and welcome to yet another episode of What Would You Like to Learn Today? Today I've been asked to explain what the current state of affairs is with modern terraforming technology and theory. Terraforming is basically when you take a planet that sucks and you turn it into a place where people can live outdoors without having to wear a spacesuit or an air mask or live under a dome or crap like that, okay? There are basically four things that you need in order to have a habitable planet, okay? First of all, you need an atmosphere, alright? Because you need something for stuff to breathe, okay? You also need the atmosphere to, if you can't breathe, you can't live there, okay? Secondly, you need a magnetic field. And this is basically because there's so much radiation whizzing around in space, the only way to deal with it productively is with a magnetic field. Around something as big as a planet, the magnetic field particles come in and they get deflected by the magnetic field and they get swirled around and they go into the North Pole or whatever, but it doesn't harm the rest of the planet, okay? Now we also, if you don't have the magnetic field also, then that can cause your atmosphere to be stripped away by all the radiation and the solar wind, okay? Now you also are going to need a H2O in liquid form, okay? So this is really, it's two things. First of all, you need lots of water, and second of all, you need to be at a distance from the sun where you're going to have liquid water, somewhere between 0 and 100 degrees Celsius, for at least part of the time, okay? Minnesota is technically habitable, even though most of the time it does not have liquid water present on the surface. Let's see. Lastly, you need carbon, hydrogen, and oxygen, okay? And that's because that's what you need in order to have biological compounds. All the biological molecules organic chemistry is all about these three elements, okay? Now, currently options for terraforming are not great because we don't really have enough technology. Changing an entire planet is kind of a massive endeavor, and we can barely keep ourselves from fucking up our own current planet. We're not really at a level yet where we can take a planet that is nowhere near habitable and try to make it habitable. But there have been some interesting ideas, and let's run through some of those real quick. Okay? By the way, what we're listening to right now, this is Holst's The Planets, some of the highlights. Every time anybody does a lecture about planets, they play this music, so you should know it, I guess. Anyway, here's the deal, okay? We've got a solar system with a sun at the center, okay? And then all the other planets are arranged outward of it, okay? The only ones that we probably could have a shot at living on, realistically, are the Earth, which of course we're already on, okay? And then there's Venus, which is slightly further in, okay? That's Venus. And then there's also Mars, which is slightly further out, okay? And the problem is that Venus and Mars, because of their locations, are already kind of handicapped. Venus is too hot because it's too close to the sun, and Mars is too cold because it's too far away from the sun, okay? Venus has a carbon dioxide atmosphere that's 90 times as thick as the Earth's atmosphere is. So that's a problem. But it does mean it has lots of carbon and oxygen, okay? Mars has a little bit of water frozen. The idea is that they think there's a lot of it under the surface. But the problem is that Mars is just too goddamn cold, okay? And its core is no longer molten. Like the Earth and Venus, they have molten cores. The iron is still hot from when the planet formed. Mars was too far out, so it's kind of gone dormant, okay? And that's going to be really, really hard to wake up. Let's see. So the ideas are, also Mars has no atmosphere to speak of. It's like 1% as strong as it is on Earth, so you can't really breathe anything there, okay? There are a couple of plans, all right? So let's think. With Venus, I think Venus is going to be our best shot, frankly, at creating a Terra-style planet, okay? Because it's approximately the same size as Earth, so it has the gravity is going to be the same. We won't really have to be too confused about that. Mars is substantially smaller, which is going to affect the amount of atmosphere that it's able to maintain also. Now, what we need to do with Venus is we need to add a lot of water, basically, okay? It's got all this carbon dioxide, so it's got lots of carbon, got lots of oxygen, but it needs lots of hydrogen, and the best way to do that is with water, okay? So what we would do is we would go out way out in the outer solar system, and we would find a comet, a big, huge ice chunk. Maybe more like an ice planetoid, okay? We need something big, all right? And we would, somehow, this is the part where it gets a little fuzzy because the technology isn't up to it, we would nudge that ice comet into an orbit that would eventually come around and smash into Venus, okay? The idea is that suddenly is going to do two things. First of all, it provides an enormous amount of hydrogen. Second of all, it raises the temperature of the atmosphere. Okay, currently Venus is hot as all bejesus. It's somewhere around 650 Kelvin. But in order to make a certain process work that I'm going to show you in 1 second, you need to be up at more around 800 Kelvin. Okay, the process is called the Bosch process. What you do is you take CO2 and you add it to hydrogen, and you do that at a very high heat. So the hydrogen is coming from the ice boulder, etc., and then the carbon dioxide is coming from the air. When you get it hot enough, which will occur when the comet hits it, then it should all submerge. You'll end up with solid carbon plus more water. Okay, a lot of the ice comet will also be, as it breaks up, it'll form oxygen. Okay, so enough of that, and we should get Venus into good shape. Okay, we also need to get it spinning. Currently, Venus only. A Venusian day is about 8 months, so we need to speed it up. So maybe we could hit the comets in at kind of an angle, put some English on Venus, get it spinning up. That'll get the magnetic field doing what it's supposed to be doing, and then we could very well be in business. Then we seed the atmosphere with bacteria that start to make various organic substances, and then before you know it, Bob's your uncle. Okay? Then it becomes a question of succession in an extreme environment, but still not that difficult. Okay, with Mars, pretty much our only hope is going to be if we can get it so it goes into the sun within the corona, and then remelts the core, gets it really hot again, and then we take it back out. Problem is that in order to get it close enough to the sun, we would have to go past the Roche limit, which is it's basically you can only get so far away from the when you're in orbit around something, you can only get so close before the tidal forces will pull you apart, assuming that what you're in orbit around is a lot larger than you. The sun is a hell of a lot larger than Mars. So if we get Mars too close, then it's going to get ripped apart. Okay, so really our best bet would be to set up some kind of mirror system, probably at like a Lagrange point, which is 60 degrees off from the sun. Okay, there's a stable gravitational point. There's one over on this side too, and there's one on the opposite side of the sun. There's also one right about here and one right about here. But anyway. The point is you can stash stuff there, and it'll just kind of move around with the sun and Mars. So we could put mirrors there that would catch the sunlight and bounce them over to Mars, so that then there would be more heat moving that way. Okay. Simultaneously with Venus, we could put some little mirrors in the way that would deflect the light from the sun away from Venus, so that then you wouldn't have quite so much incident sunlight, and it would be able to cool itself down a little bit. Okay. Because we got to get it down to a point where water can be liquid instead of gaseous. Okay. All right. Let's see. The real problem with Mars, though, is that no matter how hard you try, you're still not going to be able to overcome its small size. So you're going to need some kind of way to keep the atmosphere from escaping. Magnetic field is a good start, but if you really wanted to be able to have like Earth normal pressure, you might have to take some slightly more unorthodox measures.
There it is, planet Druidia. And underneath the air shield, 10,000 years of fresh air. Must get through that air shield.
Okay, and now, the lightning round. Boob jobs. Okay. Boob jobs are cool, I guess. They're a little frivolous, but then isn't most of what we do. I hear that in some cosmetic surgery outfits in Czechoslovakia, the demand for nurses is so great because of the recession. A lot of women are going in to upgrade themselves, as it were, in hopes of getting better jobs. This is what you get in a post-communist society, I'm afraid. Everybody's really sexually harassing, but it's institutionalized. So in order to get the nurses to come work at the surgery center, they're offering free boob jobs for the nurses. Interesting. And they're it's like giving them a company car. You're getting company boobs. Interesting. Luck. John Milton says that luck is the residue of design. But John Milton's pretty weird. Luck's a good thing, but you have to remember that there's bad luck also. We have a word for miracles when something happens that seems completely out of the blue that's really good, but we don't really have a word that means the same thing for when something really bad happens. Luck is capricious, as you know, but sometimes it works when it's a residue of design. All right, HDTV. It's basically we've had HD technology since the 80s, early 80s actually. Reagan was all on board with it. The problem is that it takes up so much bandwidth that it isn't until only recently that we've had enough on terms of cable TV. You can put it out over a cable, but you can't put it out over a broadcast nearly as easily. And there's been a lot of the main problem was in transmission, not in production, if you get what I'm saying. Now it's well established. That's what we're using. Everything's switched to a different aspect ratio, and we're using Blu-rays. So that's that. Lastly, puppies and kittens. Somebody noticed that puppies and kittens look a lot cuter than babies. That's because puppies and kittens are fuzzy and cute, whereas human babies look like Winston Churchill, who, although he is a nice guy and a great statesman and warrior in many respects, is not exactly easy on the eyes. So that's that. If we want babies to be cuter, we need to dress them up in plush suits, which many people do. Now, let me know what else you'd like to know. Have a good day.